Let's start by talking about the background of the project. In the time of Industrial 4.0, more enterprises and companies are adopting machine learning and AI as they can help the business in various ways. Modern machine learning and AI use algorithms like neural network and deep learning, and these algorithms require GPU parallel processing power to come up with satisfactory results. Current existing solutions that provide GPU processing power include consuming services from cloud service providers like AWS and Google Cloud, and the other option is to buy your own GPU card and train it on your own machine. However, there are weaknesses in both solutions, and GPU Yacht is created to address the issues with existing solution and also as an alternative to provide GPU processing power. The problem statement can be seen from two different perspectives, from an organization perspective and also from a user perspective. From an organization, as I have mentioned, buying a dedicated GPU workstation is one of the existing solutions. However, according to a study, most GPU boards are underutilized. They are utilized less than 30% of the time. The GPU depreciate over time as newer GPUs are introduced. GPUs are not worth the money if they are underutilized all the time. Now let's see from another perspective. A user that wants to train a machine learning model. A user will find it very difficult to set up the proper environment to train the model using parallel processing. The setting up of such environment requires different libraries and drivers to work properly. These are the screenshots that I've gotten from the official TensorFlow page on how to set up the environment to use GPU for TensorFlow application. TensorFlow is a popular framework that is used to train machine learning model. These requirements for the environments are very complicated and may cause many compatibility issues. If you are using Windows machines, there are even more requirements to meet. However, there's a recommended way to set up the environments as shown here. This method uses Docker containerization technologies. The Docker is a virtualization technology similar to VM, except that it's more lightweight. In this approach, Docker is used along with NVIDIA Docker package to set up the environment. And this approach is what we'll be using to create the system. Docker also provides benefits like using different versions of a same library in a same host. For example, TensorFlow version 1 and version 2 can run in two different containers without any issues. Now we have seen the problem from two different perspectives. First, organizations brought GPUs but want to make use of their underutilized GPUs. And next, the users that find it difficult to set up parallel processing environments. Now, this is where GPU Yacht, our system, comes in. GPU Yacht can be set up by the organizations to utilize their underutilized GPU to provide services to the users that do not want to deal with the mess of setting up GPU environment. It could be the users not having any GPU as well. Now I'll demonstrate the use case of users submitting requests to train a machine learning model and obtain its model. In the process, user does not require any GPU to get a model trained. So now we are looking at the dashboard of a user, and then now we would like to submit a new request. So here we enter the information, so we'll just use a random name and then select a Docker image. So a Docker image is actually a definition on how your request should be processed. So for this image, we can actually find what it's doing by looking at the documentation of this image on Docker Hub. So for this image, it's using TensorFlow version 2.4.1. And then here we have the input expectation for this image. And for input file, we should have this kind of hierarchy. And then here we also have the sample parameters that this image is expecting. So the output is a TensorFlow model that can be loaded using TensorFlow library. And we also have the JSON schema. And JSON schema is actually what we are using to dynamically load this form. So I've prepared a set of parameters that we can use, and then we'll just use the parameters that I prepared. So now we'll upload the input file. So as you can see here, the progress bar can be seen on how the image is uploaded. And the input file actually have the hierarchy that we have seen just now on the documentation page. And now we can see that the request has been successfully created. Now we go back to the dashboard. And now we can see that there's a new request on the request list. And we can click it and see the detail of the request. So it's at pending stage. Currently, there's no worker running, although it is showing checking. There's no worker running right now. In fact, the main server is the backend is made up of two main components, which is the main server that is that provide data for this side, and also task worker. So the main server is actually just a queue system to store job, but it doesn't really process the task. The task is actually processed by the module called task worker, which is not hosted which is not hosted here. And then for the task worker, I would like to run it on my personal laptop. So here I have this jar executable, which is the task worker, and it's on my desktop, and I will be using Windows Shell to run this jar. And now we can see that the server is running up, the task worker is running up on my system. Okay, so it's initializing. So as you can see, it has successfully pulled a request from the main server, and here it states that the container is run to process the request. So we can use our Docker desktop to see if there's any Docker container running. So here we can see a new Docker container is running right now, and then we can inspect the information of this container. So we can see that the information that we have here, you can see that the request ID, we will compare it with the one we have on user interface. So this ID is actually the same that we see here. It ends with 0E08. So this input parameters is actually base 64 encoded of the parameters that we have here. So now the container is initializing. Here we can also see some cooldown information that is used to do parallel processing. And now we can, while waiting for the container to start initializing, we'll have a look at the GPU yard system. We'll have a look at the landing page. So this is the landing page for GPU yard. So you can actually see some documentations or project description, and then some simple use case. So this is what we have done just now. First step is select a Docker image, and then we enter the parameters. And now we are at this stage, submit and wait. So we have submitted the request. Now we just have to wait for the request to be processed in the task worker using Docker container. And later on, we'll be able to download the files after the request has been finished processing. So I've also written the documentations for this system. So it will include the system architecture from physical aspect and also logical aspect. Also some explanations of the backend component. Then the workflow, the detailed workflow of how a user submit a request until the user can retrieve the output of the request. And then we also have the technology stack that is used to create the system. As you can see, the main building blocks will include Spring Boot, React.js, and also MongoDB, and other additional technologies and the environment that I use to do the deployment, and also some development tools and IDE. And then roadmap sections will include the target for the future work for this system. And then it is a community-driven project, means that everyone can create any Docker image, which means that everyone can write any script to be used on the GPU yard. So now I have this image that can do binary classification for text, but anyone in the public can actually write another image that can do other other machine learning model training, such as RNN or all those kind of machine learning model. And then I have also written some potential projects that can be extended from this project. And then lastly, I have also included the installation guide on how to set up the system, for front-end setup, DB setup, the main server setup, and task worker setup. For task worker setup, you actually need to set up a little bit environment to run GPU accelerated application. So you need to install Docker and then NVIDIA Docker, which provide GPU accelerated environment for container, and some little details for the task worker. Okay, so now we'll have a look at our Docker desktop. So as now we can see that the container has started training the model using, as we can see here, is using a physical device type of GPU. So this is what we have been training. So you can see that currently it's at epoch 9. So we'll just wait and let it process the last epoch. So if I refresh this page, we can see that this request is actually under processing status. So yeah. So if we see, so now we have seen that the request has been completed, and then yeah, so we can actually refresh this page, and we can actually see that the request has. Let me refresh. See that the request has turned into a complete status, and then now we can download the output file. So I'll be downloading it in my Google Drive under my demos. Then I'll extract the output file. So you can see that this is actually the safe model is actually the output of the image. So now we have successfully retrieved our output file, and then I'll show you how this output file can be used in our sample TensorFlow application. So now we can see that this is a Python notebook that I've created to test if this trained model can be used. So now I'll just run the notebook. So now I'll connect the notebook to my Google Drive to retrieve the trained model that I've extracted just now. So it actually connects to my Google Drive. So as you can see here, you can actually see my drive content here. The safe model that I've gotten from GPU Yacht just now. Okay, so now some pre-processing, and then now pre-processing step. Then now here we are loading the model from my Google Drive. As you can see here, the safe model. And then we further compile the model because we want to accept raw string as the input for this model. And then now we can do some prediction based on the model that we have loaded just now. So the whole process in the Python notebook does not involve any training at all. So it just load the model that we have trained using GPU Yacht. So we can actually change this and check if the model works just fine. So as you can see, the increase in score means that the accuracy is pretty good. Yeah. So we can also evaluate using our data set, and it has accuracy of 80-something. Has an accuracy of 87%. So here I finished my demo using GPU Yacht. So in summary, we have used GPU Yacht to train our model, and then we have also demo how the loaded model can be used to do some prediction. So this is how GPU Yachts work. Now we'll have a look at the system architecture. This system is a highly decoupled system. The front end is hosted through AWS S3 static hosting, while the backend main server is hosted on AWS EC2. The remote worker is my personal laptop with proper environment setup such as Docker Engine and NVIDIA Dockers. While AWS is used for deployment, it's not compulsory to deploy it on cloud. It's just to demonstrate how the system is decoupled. Now this is the overall module diagram. It shows the scope of this project. This shows the technologies involved in building this system, and for more information, you can find it on the website, link in description. Now, we'll talk about the potential users of this system and the benefits that it can bring. First, it can be used internally within an organization. GPU Yacht introduced a simple way to set up multiple user and multiple GPUs environment. It also provides the ability to add or remove GPU easily. Next, it can be deployed at learning institutions. Note that a dedicated GPU card can be very expensive, especially for students. By setting up a GPU Yacht, the learning institutions can share GPU processing power with the students. It encourages active learning as resources are available to the students. And lastly, it can be set up for commercial users. It can be used to sell services to process GPU-intensive tasks such as training a machine learning model. Some people will prefer not to invest in a dedicated GPU as they may only need GPU processing power for a few tasks. And thank you so much for your time.